Hello, this is the week 4 review for CRY2 Andromeda group project. I am Jeremy Prater. I guess we'll start with reviewing the goals for week 3 and what we got done. So implement data storage and transformation from data returned by Exchange. Begin storing training data. Agree on interface for backend and front end to communicate. Now it's kind of vague, the backend and front end of what. So is it the back end and front end for the training and TensorFlow pipeline, or is it the back end and front end for the website? So that could have been more specific. We did talk, myself and the other team members did talk a little bit about how we would transfer data back and forth between the training, like a simulated wallet kind of deal. But yeah, that could have been a little better. So I'll start with the architecture diagram. So Cryptopia API comes in, and we use a wrapper that basically wraps all these HTTP REST calls, and then those will get stored in a MongoDB class up here, historical storage. And then data store is kind of a class that manages transforming that data from a format the Exchange gives us into a format we store in the historical storage database that will be good to feed into the input pipeline of the neural network. Event timer is also completed. It's basically a little timer class that will instantiate, or you instantiate it with kind of a template. So you can think of it kind of like a task in like an RTOS environment. So I have created basically a thread pool kind of situation. Here's the Exchange. It's very busy with lots of numbers and colors, so it's whatever. Here is kind of the public API for the Exchange. Get currencies will return a currency and some basic info about it. A trade pair returns information about two currencies and how you can trade between them. Get markets will return sort of the high-low volume, open-close, change, kind of the basic market data. Get market is the same thing. Get market history is the closed orders that have occurred in the past. Get market orders and get market order groups call the same thing, and these are open orders that have not yet been fulfilled. And this is kind of like an indication, like if there's a ton of buy orders that just occurred, then there's some volatility occurring in the market. So for the Python code, we'll start with Cryptopia get because it's kind of the simplest. This fetch URL function is a wrapper that you give it a URL and a callback, and then it will get the contents of the URL and give it to the callback. So it's basically error handling, network retries. If the error says 502, I'm too busy, it'll try again. Or if like I would go out of range of the Wi-Fi, or if there's whatever interference, this will help mitigate network issues. And then for the individual functions, you've got a function like update currencies. It'll go to the Exchange, get the currencies, and then the callback is a function inside of that function. You could write it. I could have written it differently. I just felt doing it this way was kind of kept everything nice and encapsulated. It will, in this case, it will append a dictionary key named type and assign it to the type of whatever dtype is, which in this case is currencies. And I could go into the data structure, and I've kind of made it a little complicated, and we can look at it in a second here on the MongoDB visualizer. Get trade pairs also does some things. There's this interesting part here where it will create a list from a filter from an existing list and use a lambda function to filter out items I don't want. So it's very, I guess you would say, Pythonic. I'm iterating over the list, but it's all contained in one line of code, and this lambda function here makes it quite simple to write. Efficiency-wise, there's probably a better way to do it, but yep, it's Python. Yeah, so you can go with all these functions, and they're just wrappers for that. Andromeda is the main entry point for the program. It initiates a logger, starts some stuff, initializes the data store, and passes in. So this data here is actually kind of important This will define, I guess, the current data set that we're working on. So we're going to call it the CRY2 5-minute epoch version 2. And our epoch is going to be 300 seconds. So the epoch is how often we want to loop through every trading pair on the exchange to get the data and then save it into the database. So we can say that one frame of time from the exchange, this epoch, is 300 seconds, which is 5 minutes. So that's why it's the 5-minute epoch. And so having a smaller epoch generates higher requests to the exchange, generates a larger working data set with higher resolution, but you'll have more memory usage, more hard drive usage, more, because we're using MongoDB, so higher network bandwidth requirements. So you get kind of pros and cons. If you want resolution, you have to trade off data size. And then data store, this is quite complicated. I don't think I have the time to go into all the details of it because I wanted to get into actually what it looks like when it is outputting data into the database. The one important thing, I guess, here to start here is this self.events is the template for those worker threads that I kind of mentioned were like an RTOS, where you have a task that occurs every time period. So for get trade pairs, we'll get those every 86,400 seconds, so once a day. We'll get currency information once every 12 hours. We'll get the market data once every epoch. And then this one is market get historical orders, and that's set for 100. But then I have a note here. This will be overwritten when trade pairs are loaded. And that is kind of important because here we're saying we're updating this value before the task is created. And we're saying let's set it to the length of the epoch divided by the number of trade items in the set. So if we have a 500-second epoch and 500 items in the 500 trade pairs, then we'll have one update per second, which is a nice number. The exchange will be happy with that. But say we're trying to target like a 60-second epoch, so 1 minute. So 500 seconds is a long time. So we're trying to target 60 seconds. We want to get all the data in 1 minute. So now we've got 60 divided by 500, and so that's a fraction. I have to look through the number, but it's a fractional unit. A few milliseconds probably between every event firing. So now we're going to be hitting the exchange with a lot more requests, and also the MongoDB with a lot more requests. And if you look. Warning. So if the market history frequency times 60 is greater than 500, so hey, we're getting more than 500 requests per second to the exchange, you get a warning for that. If you go over 750, you get an error. The exchange says you get 1,000 requests. Actually, this should be per minute, so I'll have to go back and change that. That should be per minute. Yeah, if you go over 1,000 requests per minute, they'll ban your IP. So we'll give ourselves a little buffer. So 750 is kind of the maximum that I would feel comfortable with. Event timer is just the framework, and then logger is just some more framework stuff for outputting fancy colors in the logs. Okay, so we're running out of time here. Supposed to go for 5 minutes, and it's already 8. Database. All right, so here is database. We'll see that our working size, our data set's already 500 megabytes. Storage size on the drive is 319. Average object size is about 500K. Each object, so the maximum document size in Mongo is 16 megabytes by default. So that can be pretty large. It looks like this isn't working. It's supposed to be able to browse the data. Okay, well, it looks like looks like something happened to the network. So this was running. Yeah, something happened to that laptop downstairs that this is running on. So a few minutes ago, this was going, and everything was flying around the screen. Yeah, I'll just have to restart this video, or I'll just pause it and then. Okay, now we're back with the computer running again. I should probably fix that. It's a ancient old laptop that has a wiggly power connector and will randomly turn itself off. Okay, so we've got top running here, showing system utilization. Mainly I was concerned about RAM usage because having the data set loaded into RAM, Python, after about 40 minutes of running, consumed all of the RAM, 4 gigabytes. So it's not really a feasible solution. To get a full training data set, you need about 100 epochs. And if they're 5 minutes each, it's like 500 minutes, which came out to like right over 8 hours. So we need 8 hours of collecting data to have something that works. On the bottom here is Mongo Express running. This is the system log for MongoDB. Here's where Andromeda will run, which I haven't started yet. So I'm going to go into the collection. It's going to take a second to load documents. It's still alive. Maybe I need to oh, there it goes. Okay, so yeah, it's a huge data set. So we're going to delete all these documents. So we just blew away the whole data set. So now we can recreate it from scratch. And I can show you what the startup process looks like. So start it up. We get URLs. We're adding trading pairs. Now if we look, we'll start Mongo top also, and then we'll watch the I/O utilization of the database. So we're putting in a small amount of time because our working set's pretty small right now. I've seen those go up to like 900 milliseconds. So now we're collecting data. We're stuffing it in MongoDB. Let's take a look at what it actually looks like. Well, it came back. All right, so there's 515 documents. The first one is kind of an admin set, which will just be the trade pairs. And you kind of want to avoid looking at these documents in the browser because they could be thousands of lines long and megabytes in size, which will not work well for your browser. So we want to look at a specific trade pair. We'll say Litecoin versus BTC. We'll filter, look at what we got. Probably nothing yet. It hasn't gone through an epoch, so we probably haven't collected all the data. All right, we got trade pair, currency info. Oh, there's some epochs. All right. So epoch, and this is the ID of the epoch, which is defined on the current time divided by the epoch duration. So we get an integer. Oh, and then so it's a float, and then we just floor it. So we get an integer to say, hey, this is what frame of time we're in. And then we just stuffed all the data from the exchange output, which is in like blobs of JSON data. And we have stuffed that into our nicely key value pair non-relational database. And next step is to stuff this data into the input of a network, which we will design, that will hopefully predict or rank trade pairs to have a maximum return. Thanks.